Welcome to eCraft. This video is a continuation of the simple yet elegant internet clock. It uses the ESP32's capability to act as a client to pull time information from the NTP server. In this 2.0 version of the clock, we will utilize an ESP32 based board with a built-in 1.14-inch TFT LCD display. In this channel, we have posted another video that introduces the TTGO T-Display board. For your reference, the link is provided in the description box. Feel free to check it out at your convenience. For the internet clock project, the TTGO T-Display board is a suitable hardware platform. The board is based on an ESP32 microcontroller, which can be programmed as a client to connect to an NTP server. Additionally, it has a built-in TFT LCD display where the time information can be shown. The 1.14-inch display on board is connected to the SPI interface available on the ESP32 processor. The TFT display's SPI pinout connections to the GPIOs of the ESP32 processor are shown in the picture. We will need to note down the GPIO number details for the Arduino sketch. The ESP32 core library includes two functions that are necessary for ESP32-based boards to configure and obtain time from an NTP server. The first function, called config time, allows for connection to NTP servers, setting an offset from GMT, and optionally enabling daylight saving time. The get local time function creates a time structure with detailed time information. In the previous video on this topic, both of these functions were used in the sketch. In the current video, we will learn about the time structure, which will enable us to read and use time information in our program as required. For example, to detect when the date changes, we need to know how to extract the date from the time structure. The time-related information in the TM structure is displayed in the table. Member variable names are listed in the first column, allowing access to variables. In the Arduino sketch, the print local time function declares time info as a TM structure, which is then passed to the get local time function. The individual members of the time info structure are accessed as variables. We will use these variables to detect any changes in their values and refresh only the pixel blocks that display that information. Please make a note of the format specifiers for the time information, as these are necessary for displaying the corresponding values. In fact, there are many more options available. Feel free to browse through the list, which is available on the webpage provided. Since we are familiar with accessing time information, let's concentrate on displaying the time and date information on the built-in display. The initial steps involve including the necessary libraries to access the display using the SPI interface, defining the SPI pinouts, and creating the TFT object. In the setup function, we initialize the TFT LCD display. Please note that the pixel size of the 1.14-inch display is the input to this function. We will use the display in the horizontal orientation, so the set rotation function is used. The screen is refreshed using the fill screen function. We will use the set cursor, set text size, and set text color functions throughout the sketch. Let's take a closer look at the function for setting text size. The display on the TTGO display can be envisioned as a pixel matrix, where each square in the Excel file represents one pixel. By default, the text size is set as 1, which allocates a rectangular block of pixels arranged in 6 columns and 8 rows. Please note that there is a blank column and row at the end to create space between the adjacent characters. When the text size is set to 2, 1 pixel is formed by 4 pixels arranged in a 2 times 2 fashion. Therefore, each character is displayed using a matrix of 12 times 16 pixels. Similarly, for text sizes 3 and 4, 1 character is displayed in larger pixel matrices. We must consider the text size when determining the starting coordinates for character location. A function, print local time, is written to display the time and date information on the LCD. This function displays the time in hour, minute and second format. Below the time, the date is displayed using the format specifiers discussed earlier. Before displaying, the program checks if a variable has changed from its previous value. For instance, the second value changes every second. Whenever a variable changes, the corresponding pixel matrix is updated by filling the rectangle with the color black. You will notice that when the date changes, the fields on the display showing the hour, minute, second, date, and day of the week go blank first, and then the new values are displayed. Here it goes. Thank you for watching. We will add another feature in the next one. See you then.